Hello everyone, I am Krish. In this tutorial we will see about scheme. And we will see how to define a function, conditions and list. First we will see what is scheme. Scheme is a dialect of Lisp. It is your functional programming language. It uses the functional components of Lisp. It is generally used for teaching and it was developed at MIT in 1975 by Sussman and Steele. At the time it was an improvement over the Lisp language. Scheme uses static scoping. First we will see 2 plus 5 plus 3 how to convert into scheme. In scheme first you will get out the operator and put it in after the bracket and but the 2, 5, 3 close the bracket. This is way to convert in scheme. Secant 1 2 plus 5 plus 3 minus 8. Get the minus out. And do 2 plus 5 plus 3. After add the minus 8. Let us do one example. Convert the expression to scheme. First convert square b minus 4 asterisk a asterisk c. Secant b plus square b minus 4 asterisk a asterisk c. Finally add slash do asterisk a. These are the steps to convert this expression to scheme. Let us see the answer. Now we will see how to define function in scheme. Let's see the power function x to the power 3, and how to convert into scheme. When we are writing a function, first we will define the function name and we need to use define keyword. In this example we are define a function called cubex. Define is the key word in cubex function name. How to define a condition in scheme. So in here we will compare xy with scheme conditions. In this function if and else conditions are available. First define cont keyword and star the if part. Open and close bracket. Inside of the bracket write the condition and the expression. Same as else part. Inside of the bracket write the expression only. Defining the function compare x and y. Condition if x less than y we will give the expression x is less than y. Or if x greater than y we will give the expression y is less than x. Or else condition x and y are equal the expression is x and y are equal. Let us do fact example fact n equals n asterisk fact n1. And we are converting to scheme. Defining the function fact. Condition if n is equal to 0 return 1. Or else condition fact and 1 and asterisk n. In this we are calling the function again. So we will see the processing we are call the function with fact 5 and it will give asterisk 5 and fact 4 again. After fact 4 will run and it will call fact 3 and fact 3 will call fact 2. Likewise fact 0 function will give 1 as output. It will return to fact 1 function return 1 asterisk 1 to fact 2. Fact 2 return 2 asterisk 1 to fact 3. And fact 3 return 3 asterisk 2 to fact 4. And fact 4 return 4 asterisk 6 to fact 5. Finally fact 5 return 5 asterisk 24. Answer is 120. Example x2 3. This the function it will return 8. How to do in scheme. 2 power 3 equals it will return 8. 2 asterisk 2 asterisk 2 equals 8. We will check as x equals x asterisk x power y. 1. Defining the function x y. X is the number, y is the power. If y is equals to 1 return 1. Else asterisk x and x y 1. List in scheme. The cell model is commonly used to understand the implementation of lists in scheme. A list is represented by a linked list of cells. Each cell contains a pointer to the atom or list and a pointer to the next element of the list. A BC Example: the console representation of the list of BC. For historical reasons, the pointer to the atom is called a car. The pointer to the list is called the CDR. Although alternatives for car and CDR have been proposed, such as first and rest or head and tail, it is a happy accident and assists programming by suggesting a convenient shorthand. What is car? When we are calling the car L1, it will give true. It will return head in list. Car L1 return true. Car L2 return B. Car L3 return BG. Car L4 return empty list. What is CDR? When we are calling the CDR L1, it will give 5, 8, 9. It will return tail in list. CDR L1 return 5, 8, 9. CDR L2 return FGK. CDR L3 return HR. What is cons? Cons is the function joined to a list. Cons 1, 2, 3 in a BCD. Return 1, 2, 3 a BCD list. First, we are calling myScheme function to 3, for list and cons square to myScheme 3. 4, we are calling myScheme function with 3, for list and cons square 3 myScheme 4. We are calling myScheme function with 4 list. It will give cons square for myScheme, and here are calling myScheme function with empty list. MyScheme empty list function return empty list to myScheme 4, and myScheme 4 return 16 for myScheme 3, 4 function, and myScheme 3, 4 return 9, 16 to myScheme 2, 3, 4 function. Finally we have 4, 9, 16 list.